Lesson 5-1, Day 1, Part 2. This is going to focus on circumcenters, which is technically in 5-2, but it goes along with perpendicular bisectors. We have a Desmos activity that we are now going to do as a class. So you're going to need to go to Canvas and pull up that Desmos activity so we can do it together. But I'm going to continue on with the notes here. Terminology, circumcenter. When three or more lines intersect at one point, the lines are said to be concurrent. The point of concurrency is the point where they intersect. Circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle. So the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. The circumcenter is always equidistant from the vertices. So the lengths of each of those green segments that just came up on that triangle are going to be the same. Those are all congruent segments. We're connecting the circumcenter to each vertex. List the perpendicular bisectors. Segment DP, segment PE, and segment PF. There are all the perpendicular bisectors. The circumcenter is point P. List all congruent segments. Well, we already talked about all of those. Segment AP, segment BP, segment PC, all those green segments I already said were congruent. But since it's perpendicular bisectors, we have other ones that are congruent. So those are congruent. So segment DB is congruent to segment DA. Those are congruent to each other. Segment AF is congruent to segment FC, and those are congruent to each other. So segment EB is congruent to segment EC. Circumcenters in triangle types. We discovered this when we did our Desmos activity. Depending on the type of triangle, the circumcenter of a triangle will be located in different places. That first one, an acute triangle, is always going to be inside the triangle. If it's a right triangle, it's always going to be on. It'll be at the midpoint of the hypotenuse. An obtuse triangle, all the perpendicular bisectors are going to meet on the outside. So the circumcenter can be inside, such as acute triangle, on, such as a right triangle, and outside of the triangle, as in an obtuse triangle. Recall Pythagorean theorem, because we're going to be using this a lot. Parts of a right triangle. A and B are both legs. C is called the hypotenuse, and is always opposite the right angle. What is the Pythagorean theorem? We know this. We've been using it already. Pythagorean theorem is used to find the missing side length on a right triangle. It's got to be a right triangle. A squared plus B squared equals C squared. We don't plug into that. I have given you shortcuts. So you can do this. If we're looking for a leg, A can be one of the legs, and it's the square root of the hypotenuse squared minus the other leg squared. Well, same thing if we're looking for B. It's just a leg. Same idea. It's the square root of the hypotenuse squared minus the other leg squared. And then hypotenuse, if you're looking for the hypotenuse C, is the square root of the two legs squared and added together. The Pythagorean theorem, examples 1 and 2. We're going to find the missing side length x for each triangle, and we're going to show all work. We have a right triangle there in number 1. The missing side is the hypotenuse. So we're going to have to do the square root of 8 squared plus 7 squared. And we can put that in Desmos. And we get about 10.6. Number 2, we're looking for a leg this time. So now we're going to have to subtract. X is going to be the square root of 13 squared, hypotenuse squared, minus 6 squared, the leg squared. and put it in Desmos, and we get about 11.5. Circumcenter, example 1. Calculate for all the requested lengths using the given information. Use a radical and then calculate and round to 1 decimal place. We're going to put all of our answers in decimal form over there on the right-hand column. Z is a circumcenter, so we know all the properties of that is created by the perpendicular bisectors. So all the perpendicular signs are not in there, and all the congruent side lengths from the midpoints are not shown on there either, but we know them. So those two are the same length, so they're both 19, but part A is looking for TU. So the length of segment TU is those two added together, or just twice one of them. That's going to be 38. The next thing we're looking for is length of segment VY. So if we look on there, we know the length of segment VU is 34, but that's a perpendicular bisector there. ZY is a perpendicular bisector. So those two are equal, and if we cut the 34 in half, each are 17. That is the segment from the circumcenter to each vertex, and all of those are the same length. One of them is marked 21, the others are also 21. So length of segment VZ is 21, that's marked. Length of segment ZU is 21. Length of segment TZ is also 21. So UZ is what we're looking for, and that is 21. Let's see what's next. WV. WV looks like we're gonna have to use a triangle there. Pull that triangle out. We have the hypotenuse and a leg, so we're looking for the other leg. So the square root of 21 squared minus 15 squared, and put it in Desmos. We get the square root of 216, or 14.7 is how it would round. Length of segment TV, let's look at that. Well, we just found WV, and TV is twice that. So we can use Desmos to double that, and we get about 29.4. Example 2, H is the circumcenter of triangle BCD. So they're perpendicular bisectors. Not everything's marked. They are perpendicular, and they bisect the sides. So segment EH is a perpendicular bisector, segment HF is a perpendicular bisector, and segment HG is a perpendicular bisector. We need GD first. We know the length of segment BD is 24, so we just cut it in half, we get 12. Length of segment BC is what's next. So those two parts are congruent, so length of segment BE is 7, so length of segment BC is going to be 14. Length of segment EH, that's in a triangle. One of the sides, the hypotenuse of that triangle, is a segment from the circumcenter to a vertex. So all of those are the same. The one on the triangle we're going to use first is already marked 13, but length of segment CH is 13, as well as the length of segment HD is 13. So I'm going to pull that triangle out, and that's triangle BEH, and we want the length of segment EH, which is the leg. So we're going to do the square root of 13 squared minus 7 squared, put it in Desmos, and we get about 11. Because 1 decimal place is where the 9 is. We look 1 to the right, and that 5 is going to push that up. So we get 11. FD. That's in another triangle, that triangle right there in purple. Pull it out. We're looking for the leg. That's where segment FD is. I already said that length of segment HD is 13 because H is a circumcenter and D is a vertex. So we have a hypotenuse and a leg. We're looking for a leg. So we're looking for a leg again. So it's the square root of 13 squared minus 3 squared. Calculate. We're going to put it in Desmos. and we get about 12.6. And length of segment CD, since those two are the same, is going to be double that. And if we double that, we get about 25.3. Calculate for all the requested lengths using the given information. This is circumcenter example number 3. M is the circumcenter this time of triangle GHI. So they're perpendicular bisectors that create it. So segment MJ is a perpendicular bisector. Segment ML is a perpendicular bisector. Segment MK is a perpendicular bisector. Not everything's marked, but that is true. So those two are congruent to each other. They're both 30. And the first thing they ask for in part A is length of segment GI. So that's 30 plus 30 or 60. Length of segment MH. Now we know it goes from the circumcenter to a vertex. And it would be the same for every point or segment from the circumcenter to a vertex. But we don't know any of them yet. So we don't have enough information. But we can find it out. Length of segment GJ is 31, and those are the same. So length of segment JH is 31. Now we have two of the three sides of that right triangle that has MH as the hypotenuse. So we can find the length of segment MH by doing the square root of 31 squared plus 14 squared. Put it into Desmos, and we get about 34 for MH. So if MH is 34, then length of segment MG is 34, and length of segment MI is 34. IK is next. We have another triangle we're going to have to pull out. Is that triangle right there? Let's pull it out. Mark all of our information. We are looking for a leg. Segment IK is a leg, and then we're going to need HI, which is just going to be double that if you look at the picture. So a leg. We're going to have to do the square root, but the difference this time. So it's the square root of 34 squared minus 23 squared. Put it in Desmos. We get about 25. And if they're both 25, then the other length of segment HI is going to be 50. Okay, this is a delta math example. We're not going to have a delta math assignment yet because all the different special segments are mixed together, and we currently only know perpendicular bisector and circumcenter. So guess what this one's going to be? Okay, so those are midpoints, and we can tell they're perpendicular. So they are made by perpendicular bisectors. In this particular type of question, that's in the second drop down. And we know if they're perpendicular bisectors, it's the circumcenter, and that would be in the first drop down. Here is a perpendicular bisector example. Which statement is not necessarily true? Okay, a lot of words. Let's put it into a picture because a picture is easier to understand. We have line DE, and they say it's a perpendicular bisector of segment JL. So I would start with segment JL, and it's at point K, which means K is going to be our midpoint. So I just did a sketch there. That segment JL, K I put in the middle as much as I could as a sketch. And those, mark them equal, they're equal. Line DE I drew in is perpendicular to that. So let's look at A. Usually start with the first one, right? Segment DK. Length of segment DK is equal to length of segment KE. We already found our winner for not necessarily true. We do know that they're perpendicular to each other, so B was fine. K is the midpoint of segment JL, yeah. And due to the perpendicular bisector theorem, length of segment DJ would be equal to the length of segment LD. Identify the special segment, segment AB. That looks to me like a perpendicular bisector. We are now at the end of part 2.